Hello class, today we are going to talk about parallel lines and angles. So what we have here, we have three lines, line A, B, and C. And on these three lines, B and C, notice they've got these little arrows right there. That means that B and C are parallel. So line B is parallel to line C. These two lines that I put in between B and C, again, is a way of, it's a shorthand way to write parallel. That way we don't have to write out the word parallel. So line B is parallel to line C, and line A cuts across both of those two lines. So line A is a transversal. Yeah, so A is a transversal. And all that means is that line A goes across two other lines, okay? Now, when you have this, if B and C, the two lines that are being cut by a transversal, are parallel to each other, then we have some special things happening. And that's what we're going to look at here. Now, notice, anytime you have this, you'd have 8 angles right there, right? 8 angles, and they have special relationships. So, for example, we have corresponding angles. Corresponding angles are angles that are in the same relative position for their line. So, for example, we have angle 1 and angle 5 are in the same relative position. They are both in the top left-hand side, all right? So, angle 1, hold on, angle 1 and angle 5 are corresponding. We also have more. We have a lot of these, so let's change colors. Angle 2 and angle 6, both in the top right-hand side. So angle 2 and angle 6 are corresponding. Okay, that's not all. There's more. Angle 4 and angle 8, both in the bottom right, same position for their intersection, and so angle 4 and angle 8 are corresponding angles. And lastly, we have angle 3 and angle 7, right? Angle 3 and angle 7. All of these are in the same relative position for their intersections, and so they are called corresponding angles. Now, corresponding angles also have some other specialness going on here. If you'll remember when we did the parallel line constructions, what we did is we drew one line, we drew this transversal, and then we would copy the angle, right? And the angles that we would copy were corresponding angles. So what that means is the corresponding angles are congruent to each other. This is the corresponding angles theorem. The corresponding, that's an S. This is how you abbreviate corresponding. The corresponding angles theorem. All right. And what the corresponding angles theorem says is that if, big if there, so if B is parallel to C, then corresponding angles are congruent, okay? Then corresponding angles are congruent. Okay, so what that means, if B and C are parallel, and I know that angle 8 is 47 degrees, then angle 4 must also be 47 degrees because corresponding angles are congruent if your lines are parallel. All right? And that's what we did with the constructions. That's how we constructed the parallel lines. So we know that works because we've already done it. All right, so that's corresponding angles, but we do have some other relationships as well. One of those is alternate interior angles. Okay, so what alternate interior angles is, with this These are angles that are inside the parallel lines, and they are on different sides of the transversal. Okay, so for example, angle 3 inside the parallel lines. So we need another angle that's inside the lines, but is on the different side of the transversal, and that's going to be angle 6. One thing that's very important is for all of these, so corresponding angles, notice we had one angle up here with the intersection of A and B, and the other angle was the intersection of A and C. They're on different intersections. Same thing here. So angle 3 and angle 6. Both of them are inside the parallel lines, and they're on different sides of the transversal, and they're not on the same intersection. So I wouldn't want to say angle 3 and angle 4, because while this technically those are both inside the parallel lines and on different sides of the transversal, they're both on the same intersection, so that's no good. They have to be on different sides of the intersection. So our other pair, we do have another pair here, and that would be angle 4 and angle 5. So angle 4 and angle 5 are also alternate interior angles. Angle 1 can't be alternate interior with anything because it's not inside. Same thing with 2, 7, 8. The ones that we didn't circle already, those are not alternate interiors because they are not inside the parallel lines. Now, one other thing, if you'll notice, so a minute ago we said that corresponding angles were congruent, right? So that means that angle 3 is congruent to angle 7. But notice, angle 7 right here is vertical to angle 6, which means these two angles are congruent to each other, right? So if angle 3 is congruent to angle 7, and angle 7 is congruent to angle 6, well, that means that angle 3 is congruent to angle 6, doesn't it? Yeah, that's the transitive property. And so what this is going to be true all the time with alternate interior angles. So we have this as the alternate interior angles theorem. So let me write this down. Alternate interior angles theorem. And what the alternate interior angles theorem says is that, again, that same big if B is parallel to C, then alternate interior angles are congruent. Again, I'm going to abbreviate. Alternate interior angles are congruent. Okay, so what that means, again, if angle 6 is 138 degrees, then that means that angle 3 is also 138 degrees. If you know one angle, you can find the other angles. Okay, so that is alternate interior. Remember, that is inside and on different sides of the transversal. So let's take a look at the next one. Alternate exterior angles. This is outside the parallel lines and on different sides of the transversal. So a minute ago we talked about the ones that were inside the parallel lines, exterior, so we're going to be outside the parallel lines. So that would be angle 1, and over here on the other intersection, outside the parallel lines, so that's 7 and 8, but we want it on the different side of the transversal, so that's going to be 8. So angle 1 and angle 8. We do have another pair, and that would be angle 2, which is going to go with angle 7. So angle 2 and angle 7. Okay, and we do have a theorem for this, just like we had a theorem with those other two. So the alternate exterior angles theorem, again, I'm going to abbreviate. So alternate exterior angles, and theorem can be abbreviated as just THM. So the alternate exterior angles theorem. And let's take a look at this. So a minute ago, we said that corresponding angles were congruent, right? So angle 2 is congruent to angle 6 because they are corresponding. They're in the same position. So if I know that angle 2 is, let's say, 172 degrees, which it's not, but whatever, then that means angle 6 is 172 degrees. And oh, look at that, 6 and 7 Those are vertical angles again, so angle 7 is 172 degrees. And look, angle 2, angle 7 are congruent. And that's always going to happen. Alternate exterior angles. Still, we have that big if. If B is parallel to C, then alternate exterior angles are congruent. Alternate exterior angles are congruent. Okay. So alternate interior angles, congruent. Alternate exterior angles, congruent. Now we do have a couple more relationships we're going to look at. So let's take a look at this one. What if they are same side interior angles? Well, same side interior angles, those are going to be inside the parallel lines and on the same side of the transversal. So that would be inside the parallel lines. That would be something like angle 3. And this time, instead of being on different sides of the transversal, we went on the same side of the transversal, which would be angle 5. So angle 3 and angle 5. We do have another one, so let's come over here. On the other side of the transversal, we have angle 4 and angle 6. Angle 4 and angle 6. Also, same side interior angles. Same side of the transversal, inside those two parallel lines. Now, looking at this, we do not have congruence. Notice angle 3 is alternate interior to 6. So angle 3 and angle 6 are congruent. So if I said angle 3 was 150 degrees, that means angle 6 is 150 degrees. Angle 5 is not going to be 150 degrees, is it? No. But what is angle 5? Well, let's take a look at this. Angle 5 and angle 6, those make a linear pair, don't they? Right here, nice linear pair. Same thing we've looked at before. And as we know, linear pairs are supplementary, which means they add up to 180 degrees. So that means that angle 5 is going to be 30 degrees, because that's supplementary with 150. And look at this. Angle 3 and angle 5, well, they're supplementary too, aren't they? 150 plus 30, that's 180. So same side interior angles are going to be supplementary. So let's write this down. This is a theorem that we're going to use. So same side interior angles theorem. And this says that if, still got that same big if B is parallel to C, then same side interior angles are supplementary. Same side interior angles are supplementary. And you can abbreviate supplementary as just like this. Supplementary. So they will add up to 180 degrees. So we have one last relationship here, and that is the same side exterior angles. Just like we had alternate interior and exterior, we have same side interior and exterior. So exterior angles, that's going to be on the outside. That'll be angle 1 is on the outside, and on the same side of the transversal, we have angle 7. Angle 1 and angle 7. Outside the parallel lines on the same side of the transversal. So we do have another pair, and that would be angle 2 and angle 8. Okay. So let's take a look at this. What can we figure out our relationship there? Let's just say that angle 1 is, I don't know, we'll call this one 30 degrees. Well, what down here with the other angle do I know? Well, I know that angle 5 is corresponding, right? It's in the same position, both on the top left. So that means angle 5 is 30 degrees. Is angle 7 going to be 30 degrees? No, angle 7 is not 30 degrees. What do we do with this? Okay, well, look, hey, we've got that linear pair again, right? Linear pair with angle 5 and angle 7. So that means those are supplementary to each other. So if this is 30, then angle 7 must be 150 degrees, right? And so, because 30 plus 150 is 180, and they're a linear pair. And oh look, 30 right there, 150 right there, angle 1 and angle 7 are also supplementary. And so that's what we have here. Same side exterior angles, same side exterior angles theorem, which again can be read as THM. And what that says is that still we have that big if. If line B is parallel to line C, then same side exterior angles are supplementary. Same side exterior angles are supplementary, which can be abbreviated with that. Okay, now, very important. Notice, every single one of these only work if the lines are parallel. So, for example, really quickly, I'm just going to draw me some lines in here. So these two lines are clearly not parallel. And if I draw a transversal, notice my corresponding angle right here, this one, and this corresponding angle right here, not congruent, are they? No, because this one's obtuse and that one's acute. If the lines are not parallel, none of these theorems work. Only work when your lines are parallel. Also, remember, if you have same side exterior or same side interior, either one, then we have supplementary angles. If you have alternate exterior, congruent. Alternate interior, congruent. Corresponding, congruent. So, same side angles are supplementary, alternate or corresponding are congruent. And if you know one of your angles, you can find all 8. Because you also have, remember, vertical angles. Right? Vertical angles are congruent, and linear pairs are supplementary as well. And that is that. I hope you found that useful, and I will see you in the next video.